Astonishment swept through observers during the recent missile test conducted by the People's Liberation Army (PLA). In a momentary miscalculation, welcome to the Frontline Report, your go-to source for in-depth analysis and breaking news on the most crucial events shaping our world. At the Frontline Report, we're committed to delivering insightful commentary, expert interviews, and on-the-ground perspectives to keep you informed and engaged. Don't just follow the news, understand it. Subscribe, hit the notification bell, and join us on the front lines of information as we unravel the stories that define our era. Let's dive into today's report. The J-20 stealth fighter jet narrowly escaped destruction by its own missile. If the jet had accelerated a mere 0.5 seconds earlier, today's news headlines might have taken a tragic turn. Does this alarming incident accurately represent the capabilities of China's J-20, often referred to as the mighty dragon in the West? Regarded as the pinnacle of China's Air Force, the J-20 has never engaged in actual combat, but a recent near catastrophe has cast doubt on its technological maturity. Fortunately, the unconventional WS-10 engine played a crucial role in averting disaster for the J-20. However, the lingering question is whether this stroke of luck will persist. On June 29, 2023, a video featuring a J-20 from a Chengdu test site went viral. It wasn't the aircraft that captured attention, but the distinct orange-red engine flame and deep roar. These distinctive features hinted at the possible use of a new engine, with rumors suggesting it might be the WS-15. The online community is buzzing with speculation, with some asserting that its thrust surpasses an impressive 18.5 tons, outclassing the US F-22's F-119 engine. However, the accuracy of these claims is questionable, prompting skepticism from prominent Chinese aerospace bloggers. History has demonstrated that impressive numerical specifications don't always translate into real-world effectiveness. As the inaugural fifth-generation stealth fighter for China, the J-20 faced skepticism and challenges from the beginning. Recent flight incidents, coupled with debates surrounding its engine thrust, have only intensified the existing uncertainties. Does the moniker Mighty Dragon truly reflect the formidable capabilities of the J-20, or is it, as some video titles humorously suggest, a subject of ridicule with claims like J-20 is a joke? In its initial design phases, the J-20, aspiring for unparalleled stealth and determined to avoid accusations of mimicry, amalgamated features from various aircraft such as the MiG-144, the Rafale's wings, and the F-22's tail. While this approach bolstered its stealth capabilities, it introduced several challenges in aerodynamic stability. To address this, the J-20 had to integrate Russian-style canards, albeit at the expense of compromising its stealth. The fundamental challenge stemmed from China's limited expertise in intricate aerodynamic calculations and stealth design, making it a formidable task for the J-20 to strike the perfect equilibrium between stealth and stability. Former U.S. Air Force Chief of Staff David Goldfein drew parallels between the J-20's stealth capabilities and those of the F-117, suggesting a resemblance to first-generation stealth technology. On the other hand, Andreas Rupprecht, an authority on China's aviation advancements, indicated that the J-20 would require more time to genuinely compete with the F-22 and F-35. In a simulated exercise aimed at showcasing its stealth advantage, the J-20 found itself targeted by a ground-based Type 99 dual 35mm anti-aircraft gun, posing a clear challenge to its proclaimed stealth prowess. The assessment extends to the WS-15 engine, where its nozzle lacks a recessed design, indicating persisting issues in thermal management. The J-20 becomes susceptible to infrared missiles, significantly compromising its overall survivability. Despite its numerous engineering features, the WS-10 engine boasts a mere 1,500-hour lifespan, a stark contrast to the impressive 12,000 hours offered by the engines on US F-22 and F-35 aircraft. Although the WS-15 has shown improvement, reaching 4,000 hours, it still falls notably behind American technology. Frequent malfunctions and part wear raise concerns about the J-20's operational efficiency, potentially necessitating frequent returns to base during actual missions. While the J-20's radar performance is commendable, its exceptional stealth doesn't match up to the F-22 and F-35, making it challenging to detect these U.S. jets within its missile range, typically around 100 to 150 kilometers. The issue lies not in the J-20's radar, but rather serves as a testament to the advanced American stealth technology. Recent rumors circulate about the WS-15's afterburning thrust purportedly reaching a remarkable 18.5 tons, surpassing even the F-22's F-119 engine, with its 18 tons. However, credible aerospace bloggers express skepticism, suggesting that these figures might be exaggerated. If the WS-15 indeed possesses such high thrust, core components like the compressor and combustion chamber might need to exceed current specifications. It's crucial to note that the 18.5-ton thrust figure could originate from three distinct testing scenarios: ground stand testing, ground-mounted testing, and high-altitude flight testing. In line with past practices, China tends to disclose favorable figures, potentially indicating that the 18.5-ton thrust claim may stem from high-altitude tests. Conversely, the U.S., following regulatory requirements, typically releases more conservative data to mitigate potential legal concerns. Therefore, the F-119 engine's 18-ton figure might originate from ground testing. It's widely acknowledged that maximum thrust measured at high altitudes tends to be around 20% higher than data obtained from ground test stands. Applying this standard, the WS-15's thrust at high altitudes could be 18.5 tons, while, under similar conditions, the F-119 engine might reach 21.6 tons. Simply asserting that the WS-15's 18.5-ton thrust surpasses the F-119's 18 tons doesn't present the full context. The ultimate resolution would come from a genuine aerial duel between the F-22 and J-20. Assessing the WS-15 engine on the global stage, its thrust-to-weight ratio stands at 10, meeting fourth-generation standards. However, the US has not only transitioned into the era of fifth-generation engines with a ratio of 12, but is also actively developing sixth-generation engines with a target ratio of 15. The WS-15 engine is undoubtedly a highly sought-after technology for the Chinese Communist Party. While prototype models exist, mass production encounters challenges, primarily due to dependence on various foreign materials and supply chains, especially given the export restrictions imposed by many nations on these critical technological materials. The engine's core, particularly the tail section, must endure temperatures reaching up to 3,000 degrees centigrade and pressures 10 times that of atmospheric levels. To manufacture such material, maintaining a monocrystalline state is imperative, as any polycrystalline occurrences significantly diminish its toughness, rendering it brittle and prone to fracture. The manufacturing process demands exceptional precision, with some parts as thick as an elbow and others as thin as a fingernail. The intricate processing relies on advanced 6-axis CNC machines to ensure the material doesn't shatter. This challenge isn't solely technological, but also a matter of craftsmanship. Zhang Yang, the project leader at the Beijing Institute of Aeronautical Materials, underscores that, while some breakthroughs in engine technology have been made, producing high-end alloys and establishing a complete supply chain present formidable challenges. Many specific materials and technologies still rely on foreign imports. Therefore, for the WS-15 engine to achieve widespread use, the Chinese Communist Party may need to invest several more years of effort. Technical specifications and performance data merely scratch the surface. In actual combat, numerous other factors determine victory, encompassing weapon integration, sensor range, electronic warfare capabilities, targeting systems, tactical training, and real-world experience. Based on the available information, the US F-22 and F-35 exhibit superiority in various aspects. In a clandestine facility, an F-35 pilot engages in a combat simulation exercise with a simulated J-20 as the adversary. The electronic display unfolds a high-speed aerial duel between the two aircraft. Inside the F-35 cockpit, the pilot's helmet seamlessly integrates data from sensors scattered throughout the aircraft. It creates an immersive experience, akin to possessing a sixth sense, enabling the pilot to be acutely aware of his own movements, those of adversaries, and those of allies. Armed with this comprehensive awareness, confronting any adversary appears effortlessly manageable. Abruptly, the J-20 assumes an offensive stance, launching 4 missiles. Unfazed, the F-35 pilot maintains composure, knowing that his weapons bay is equipped with an arsenal sufficient to neutralize any impending threat. Post-simulation, the U.S. pilot expressed that when pitted against the J-20, his F-35 unmistakably holds a strategic advantage. He emphasized that it goes beyond mere missile count or fuel capacity. Instead, it revolves around each move being supported and seamlessly integrated by advanced technology. This integration doesn't confine itself to the aircraft alone. It extends to drones consistently taking off and landing on specific Pacific islands. These drones function as devoted wingmen to the F-35, always prepared to furnish valuable intelligence and firepower. For the American pilot, every flight feels like an experience at the forefront of technology, and with this technological support, he perceives an invincibility in the skies. The advanced technology of the United States has been a long-standing source of inspiration for China, a sentiment evident in various facets of their products. The J-20, publicly hailed as a symbol of cutting-edge technology, reveals a different narrative when scrutinizing its technological lineage. Yang Wei, the chief designer of the J-20, openly acknowledged that American high-tech advancements significantly influenced the design and development of the J-20. China's approach of extracting technology from wrecks has historical roots. Dating back to the Vietnam War, every downed American plane served as a potential treasure trove for Chinese engineers. They seized every opportunity to collect and study these remnants, hoping to unveil technological secrets. According to Yang Wei, since the 1950s, China has accumulated over 40,000 fragments of aircraft wreckage, leveraging them to reverse engineer approximately 300 key technologies. However, China's technological challenges extended beyond aircraft design. Faced with technology blockades in the 1980s, China encountered a bottleneck in aviation engine development. Negotiations with the UK, spearheaded by former Chinese chairman Deng Xiaoping, led to the acquisition of 16 engines from Britain's BAE Systems, offering valuable insights, despite never being flight tested. In addition to these overt means of technology acquisition, China resorted to more covert methods. The country's digital military unit, particularly Unit 61398, faced repeated accusations of cyber attacks on American defense giants, seeking to pilfer crucial tech blueprints, including those of F-22 and F-35 jets. A notable instance was the 2014 arrest of Chinese citizen Su Bin in Canada, accused of infiltrating systems of companies like Boeing and Lockheed Martin, stealing a trove of secret design documents. Considering China's tendency to reference and adapt other nations' aircraft designs, the strategic deployment of the J-20 for real-world application may lack foresight. Initially conceived as a multi-role fighter, debates have emerged suggesting a potential shift to an air superiority-only role. This strategic ambiguity is reflected in its actual equipment specifications, posing questions about its effectiveness in both roles. Furthermore, the full integration of the WS-15 engine into the J-20 is estimated to be 3 to 5 years away. By that timeline, the US's B-21 bomber and the next-gen fighter, NGAD, might be developed and operational. In light of these considerations, the Chinese Air Force must conduct a thorough analysis of the J-20's tactical and strategic alignment. It should strategize to maximize its design strengths, emphasizing a comprehensive approach beyond mere technical and tactical competition with the U.S. fifth-generation fighters.